We have a test scheduled for Thursday or Friday this week of this week of November 11th. Several people were gone today, so I decided to video the class discussion that we did. Today was only a review for this test. So I had this little thing here for a do now, where we had a periodic table test graph review, had the periodic table graphs over here. These are the same kind of graphs. I made them the same way that you guys have been making them. Don't forget that I need to check those off of your Google Docs, or your Google Sheets actually in this case. Before we begin, reminding you of the three definitions. Atomic radius is the distance from the nucleus to the outside of the atom. Ionization energy is the energy needed to remove an electron from an atom. And electronegativity is an atom's attraction for electrons. All right, so without further ado, here we go. Question number 1. The atomic number of the element with the largest radius. So you would come over here and look at your radius graphs. And we have electronegativity on the bottom. You look at your periodic table graphs. There's ionization energy in the middle, and radius is the top one. So we want the atomic number of the element with the largest radius. If you look right here, you can see that this guy here, oops. If I'm going to write on this, I've got to change that to comments and do this. So the element with the largest radius is this one up here, and that is potassium. Okay, the atomic number of this, we know this is 20. This is 19. I'm trying to do this with 3 screens. So element number 19 that I circled, if you look right here, is potassium. So that's element 19. All right, so that is element 19. Boom. Okay, the atomic number of the element with the smallest ionization energy. So now you're going to look at this graph. Which one has the smallest ionization energy? All right, after pausing for a moment there so you can think about it, you can see that it is this element. And what is its atomic number? Well, this is 20, so the one right in front of 20 would be 19. So the point that I'm trying to make here is that the biggest element, number 19, has the smallest ionization energy. Now we're going to look at electronegativity, number 3, the atomic number of the element with the lowest electronegativity. So you come over here, the electronegativity is on the y-axis, the atomic numbers are down here, so the one with the smallest electronegativity would be this one. And that element is, oh look, it's 19. So that was 19, this is 19. All right, so now when the atomic radius is large, ionization energy and electronegativity are what? So you see 19 was the biggest radius, but they're the smallest for both ionization energy and for electronegativity. So when the radius is large, the ionization energy and electronegativity are small. Okay, number 5, what's the atomic number of the first element of the third series on the periodic table? Let's go look at the periodic table. This is the first series, the second series, the third series, or first period, second period, third period. The atomic number of the first element in the third period is sodium, or it's 11, which is sodium. The last element in this period is argon. So in just the next question is, what's the atomic number for the last element in the third series, and that's argon. All right, so we know that number 5 is sodium, 11, and number 6 question was 18. It was argon. If you look over here, you see argon is 18. Now number 7. Look at the atomic radius. How does the radius change between the beginning and the end of the third period? So let's go back to the radius graph. We said that the first element was argon. So that'd be this one. And the last, I'm sorry, I misspoke. The first element was sodium. And the last element is argon. That's this one. So we're going from sodium to argon. How does the radius change between the beginning and the end of the third period? Referring to questions 5 and 6, 11 and 18, which again are sodium and argon. So the radius is getting smaller. So what I'm trying to get you to see is, as you go around the periodic table, or go across the periodic table, the size gets smaller. So you kind of, I can't write on this one, I don't think, because this is on the internet. But as you start over here big, and you go to small. All right, so decrease would be a word that would mean get smaller. Now look at ionization energy graph. How does the ionization energy change between the beginning and the end of the period? So here was element 11, that was the beginning of the period, remember sodium. This is element 18. So how did the ionization energy increase? In general, it gets what? It gets bigger. Or you could say increase. And then again, we're going to look at the electronegativity graph. It's down here. So element 11 on this graph is right here, and element 18 is this element. Oh, I'm sorry, element 17, because there isn't an 18 on this one. The reason there's no 18 is because argon is a noble gas and has its valence or outer electron energy level full of electrons, so it doesn't attract electrons. Okay. So between the beginning and the end of the period, again, electronegativity increases. So it gets bigger or increases. I'll just put bigger to be consistent. There we go. Now in the second period, there's an element that doesn't have an electronegativity because it's a full valence shell. So let's take a look at the second period. That's this one. So we're looking at elements 3, 4, 5, 6, 7, 8, 9, and 10. So the question is, which one of those doesn't have an electronegativity because it's got a full outer shell? So let me take this opportunity to remind you that this family has 1 valence electron. This one, 2. This family, 3. This family, 4. This family, 5. This family, 6. Then 7. Then 8 valence electrons. So, the second period element that does not have an electronegativity because it has a full or 8 valence electrons, let's look at it. Second period, it started with element 3. So this is 3, this was 4, 5, 6, 7, 8, 9, there is no 10. Then we go to 11. So this element over here is 11. Whoops. Right there. Okay, and this was 9 up here. So there was no 10. That is the one that does not have an electronegativity because it has a full outer shell. So that's 10, which is neon. Okay, now we're going to find elements 3 through 10. How does atomic radius change between them? Atomic radius graph. Here's element 3. Here's element 10. How does it change? It decreases. Now we're going to look for element 1, 3, 11, and 19. Are they in the same family or in the same period? Here's 1, here's 3, here's 11, there's 19. Are they in the same family or in the same period? So you remember that the vertical columns are called families or groups. Horizontal is called series or periods. So these are all in the same vertical column, so they're in the same family. All right, so our answer here is family. Now how does the size change between elements 1, 3, 11, and 19? So let's go back over and look at this graph. Size is the atomic radius. So here's 1. This element right here is number 1. This is element number 3. That's number 11. That's number 19. So how is the size changing? It's getting bigger. So how does size change as you move down a family? Do you remember that 1, 3, 11, and 19, here's 1, 3, 11, 19 are all in the same family? So the size, they got bigger as you went from those down that from 1 to 3 to 11 to 19. So any family, as you go down it, the atoms get bigger. How does the ionization energy change? Let's go back over here, come down to the ionization energy graph. Here's an element number 1. number 3, 11, and 19. So let's mark it. Okay, I'm not sure where I had that, so here. So this is 19, this is 11, that's 3, and that's 1. So how is the ionization energy changing? This one's hard to see, but it's a little bit lower than this one, and that one's lower still. Alright. Not sure how to get rid of that window, so I won't worry about it right now. So the ionization energy gets what? More or less? 1, 3, 11, 19. It's going down. So decrease. So how does the ionization energy change within a family? As you go this way, it gets less. So lower, going down. Or you can just say decrease if you can remember we're going down the family. Now we're going to find sodium through argon on the ionization energy graph. I'm going to pull this one back up again, reopen it. There we go. So now we're looking to see the sodium through argon. Remember, sodium is element number 11. Argon is element 18. So we're looking to go from 11 to 18. And the graph we're looking to go on is the ionization energy graph. So we go to here, 11 through 18. So we do that. Number 10 is right here, so this must be element 11. 20, 19, 18. So you can see that as you go from left to right, the ionization energy is increasing. All right, so left to right, ionization energy increases. Top to bottom, ionization energy decreases. It gets harder to remove electrons as the atoms get smaller. You notice as up here, if you look at this, the size is getting smaller. The energy required to remove an electron gets bigger. So those are the same elements, 11 through 18. 11 through 18. All right, now what element on the electronegativity graph has the most attraction for electrons? So we go over here to the electronegativity graph. Which one is it? The highest attraction. It's this one. What element is that? This is element 10, which is not there. The one right in front of that would be 9, or 5, 6, 7, 8, 9. Now what is element 9? So you go over here and look for it. This is element 9 up here. See fluorine right there. Okay, so that's fluorine, F. Which one has the least attraction for electrons? So you go over here. The lowest attraction for electrons would be this element right here. That's element 20, so this one would be element 19. And you go back, what is element 19? It's potassium. So we'll put K in right there. Now, from which element on the ionization energy graph is it easiest to remove electrons? That means it would have the lowest ionization energy. So you go back over here to the ionization energy. Which one has the lowest? It's this element right here. That's number 19. Back over here, remember number 19 is potassium. Go back over here, put a K right there. All right, that's the end of the questions. Let me just do a couple of things for review. So what I'm trying to get you to see is that as the atoms get smaller, it becomes more difficult to remove an electron because they attract electrons more. Let me say that again. As atoms get smaller, it's more difficult to remove an electron because the attraction for electrons goes up. As you go down a family, now remember the families are 1, this is a family 1, 3, 11, and 19. As you go down a family, the atoms get bigger, which means that the ionization energy is going to get smaller. As these get bigger, oops, the ionization energy gets smaller. These are those same elements. Here's number 1, 3, 11, and 19. So see, electronegativity is decreasing also as the atoms get bigger. So they're opposites. As atomic radius gets smaller, both the ionization energy and the electronegativity increase.